Hey, Professor Baldwin here, and today we're going to go over how to solve rational equations and radical equations. Remember, a rational equation is a fraction, and we have 5 steps that we're going to go through for these first 3 examples. Step 1, we need to find the LCD for all terms. Our LCD for this first example is 2x times 3x plus 2. That's because neither of these denominators can be factored or simplified in any way. Now we're going to multiply each term in our equation by the LCD. That first term becomes 5 times 2x times 3x plus 2 over 3x plus 2 equals the second term, 3 times 2x times 3x plus 2 over 2x. Now we need to simplify each of these terms. So the first term have 3x plus 2 in the numerator and the denominator. Those simplify out. And the last term have 2x. Now we need to simplify each of our remaining terms. This first term we have 10x. And on the right we have 3 times 3x plus 2. This is 10x equals 9x plus 2. We're going to continue to solve. So we need to subtract 9x from both sides. And we get x equals 2. Now, the last step is for you to check. The most important part of the check is to make sure that the denominator is not 0. And a quick check here, our first denominator would be 6 plus 2, or 8, and our second denominator would be 4. So x equals 2 is a final answer. Let's look at example 2. What's our LCD here? Well, the first term has a denominator of 1, and the last term has a denominator of 1. So the LCD is just x. So we multiply all 3 of these terms by x to get x times x plus 6 times x over x equals 5 times x. And then we simplify. Nothing simplifies in the first term except for multiplying the x times x, which is x squared. The second term, the x in the numerator and the denominator simplify out to 1, so we have plus 6 equals 5x. We need to subtract the 5x from both sides, and we'll see that we have a quadratic in standard form. In order to solve this, we want to factor it. And this one actually factors quite nicely. It's going to factor as x minus 6, x plus 1. Then you need to use your zero product property. So x minus 6 equals 0, x plus 1 equals 0. Add 6 to both sides to get our first solution, which is x equals 6. Subtract 1 for the second one to get x equals negative 1. Again, we need to go back to the original problem and see if a value of 6 or negative 1 for x gives us a denominator that is 0. It does not, so both of these are possible solutions. Now, how about our last example? Our LCD. Well, before we find our LCD, notice that the very last denominator can be factored as x times x minus 6. That is a combination of the first two. So our LCD here is going to be x times x minus 6. We're going to multiply each term by that. So we get 1 times x minus 6 over x minus 6 minus 1 times x minus 6 over x equals 6 times x minus 6 over, we can use our factored denominator here, x times x minus 6. Let's simplify each term first. The first term, the x minus 6's simplify out and we're left with just x. The second, the x simplifies out of the numerator and the denominator and we're left with minus x minus 6. Keep that in parentheses because we have the subtraction sign that we're going to have to distribute. And now we need to simplify the last one, x minus 6, and the x simplify, and we're left with 6. Okay, now we need to distribute this minus sign through. We have x minus x plus 6 equals 6. Simplify the left-hand side, x minus x, they cancel each other out. We're left with 6 equals 6. And your brain is probably thinking, oh no, what did I do wrong? You did nothing wrong. This is an identity, right? The left-hand side is exactly equal to the right-hand side. That means the solution is technically all real numbers, anything from negative infinity through infinity. However, we can't have a denominator that is 0. So we can say that x is all real numbers except, what can x not be? Well, for the first denominator, x minus 6, we know that x cannot equal 6, right? And for the second one of just x cannot equal 0. Both of those would give us denominators of 0. But technically we want to put this in interval notation, so we can have any number from negative infinity until we get to 0. We can't have 0, so we use parentheses. Then we can have any number from 0 through 6. And finally, from 6 through positive infinity. Now, how do we simplify radicals? Well, to simplify a radical, we have 4 steps that we need to follow. The most important step is that you need to isolate the radical term on one side of the equation. If you have multiple radicals in an equation, isolate one of them and then work through, and then you'll repeat steps 1 and 2 in order to isolate the remaining radical. In example 1, our radical is already isolated. Then we're going to take and square both sides, because if we square a radical, we're left with the radicand. So we're left with 7 minus x on the left, and we square the right, and we get 4. Now we can just solve for x. Subtract 7 from both sides. We get negative x equals negative 3, or x equals 3. Step 4 is to check your answer. Step 4 is very important. So our check here, we're going to take our solution, that x is 3, substitute it back in, and see if that equation is true. 7 minus 3, that's the square root of 4 equals 2. Square root of 4 is 2. 2 equals 2. Check. So our answer, x equals 3, is indeed correct. Now look at example 2. Our radical is not isolated. There's a plus 2 at the end. Step 1 says to isolate. So subtract 2 from both sides, and we've isolated that radical of x plus 4 on the left, and we have x minus 2 on the right. Now we need to square both sides, so we get x plus 4 equals x minus 2 squared. We need to actually square the right-hand side, and that'll give us x squared minus 4x plus 4. Now we can subtract 4, and we can subtract x from the left-hand side, and we have 0 equals x squared minus 5x, and this becomes 0. We need to keep on solving. So this is technically x squared minus 5x equals 0. We have a GCF here of x, so we factor out the x, and we have x minus 5. The zero product property tells us that x equals 0 or x minus 5 equals 0. Solving that second one, we add 5 to both sides, and we have x equals 5. So our two solutions are that x equals 0 or x equals 5. Well, we need to check both of these. So let's do our check. If we substitute in 0, we get 0 plus 4, take the square root, plus 2, does that equal 0? Well, we have the square root of 4 plus 2. Square root of 4 is 2. Does 2 plus 2 equal 0? No. So x equals 0 is not a possible solution. So let's check with 5. We have 5 plus 4, take the square root, add 2. Does that equal 5? Well, it's the square root of 9 plus 2 equals 5. Square root of 9 is 3. 3 plus 2 equals 5? It does. So our solution for example 2 is only x equals 5 because x equals 0 didn't check. Now let's look at example 3. We have two radicals, so we need to isolate one. Let's just subtract the second one from both sides. So we're going to have the square root of x minus 3 equals 5 minus the square root of x plus 2. We need to square both sides. On the left we get x minus 3. And on the right, we have 5 minus the square root of x plus 2 squared, so it's being multiplied by itself. I'm going to write it out because it'll be a little bit easier to see what you get when you FOIL. The left stays as x minus 3, and when we FOIL the right, we get 5 squared minus 10 square root of x plus 2 plus x plus 2. This last set, x plus 2, comes from multiplying the square root of x plus 2 times the square root of x plus 2. Multiplying those two radicals together, you keep the radicand. Let's continue to simplify. X minus 3 equals 25 minus 10 square root of x plus 2 plus x plus 2. Combining on the right-hand side, the left stays x minus 3. We have 27. Let's move the x up here too. Plus x minus 10 square root of x plus 2. Now I need to start isolating this x plus 2 within the radical. So how about we subtract 27 and we subtract x from both sides. Subtracting x, the x's cancel out. So we have negative 30 on the left equals negative 10 times the square root of x plus 2. If we divide by negative 10, we get 3 equals the square root of x plus 2. Our square root is isolated, so we can square both sides. And squaring both sides will give us x plus 2 equals 9. Subtract 2 from both sides, and we get x equals 7. I've already demonstrated to you how to do the checks. You're going to take this x equals 7 and plug it back into the original equation and verify that it's true. It does become true, therefore x equals 7 is indeed a solution. If you have any questions or a problem you want help with, Leave it in the comments and I'll include it in one of my videos.